Hello everyone. Okay, so in the previous tutorial, I think we stopped from uh, sprint camera transitions. So this is the implementation basically. So when the character is trying to sprint, or when he's sprinting, the camera goes backward, and once the sprinting is finished, the camera comes to the default camera mode, right? Right. So similarly, let's add another camera transition for far camera. Right. So if you remember inside our data table camera, so here like we have added 4 of the camera transition states, and similarly we need one more, which is far camera, right? So currently I'll implement the far camera using some sort of a placeholder blueprint, just to showcase its features, right? And we can later on use those features on the actual gameplay mechanism, right? For example, like when the character is climbing a ladder, maybe we can uh, change the camera mode to the far camera, right? So that the player will be able to see uh, the level in more detail, right? Or for example, when the character goes to a vehicle, then again we can use the far camera instead of using a default medium camera, right? So those are like gameplay mechanics later on we are going to implement, but currently we don't have those features. But since we are covering this camera transition related stuff closely, I thought of like covering this far camera feature here as well, right? So for now I will simply implement a placeholder blueprint to showcase the features. Okay, so first I'll implement the necessary configurations at the data table so that we can simply reuse those functionalities. Or actually we can use those configurations to configure our camera settings. Right, so first I'll add a new record and I'll save to the far camera. As the row name I'll give far camera, and as the spring arm length we can have like a higher spring arm length compared to these values. Maybe like 800 will be fine. And as the camera location I'll add some C offset, and for the field of view maybe we can give it a 80 or something like that, and play rate I'll keep it as 1. Right, then so this stuff has been configured at BP camera manager, right? So here like we have a specific function called set camera state. So based on the camera state that we are giving, the relevant camera settings will be taken out from the data table, and those settings will be applied to each of these individual artifacts to configure them at the runtime, right? So we can like now test this by maybe adding some debug key for player character. Yeah, so currently I have 1 and 2 to test this medium camera state and close-up camera state. So I'll use the same debug keys, right? So if I press 1 it will go to the medium camera, and if I press 2 it should go to the far camera, right? Right, now let's see how it works. Okay, I can see if I press 2 it goes to sort of like a far camera, right? And I can sort of see the entire, not the entire level, but relatively larger level space compared to the previous camera state, right? If I press 1 it will go back to the default medium camera, right? Also you can see like there is a small in-depth transition for the field of view as well, right? Just to make some difference. Okay, right, now this is actually a manual transitions. Actually we are sort of manually manipulating the camera states, but instead I just want to add sort of a way to automatically do these transitions. right? So for that, let's create a placeholder blueprint. So since this is camera related testing, I'll go to the camera and create a new blueprint class called pp camera test. And this one essentially implement maybe a sphere collision, right? So that we can use we can actually use this one to detect the player collisions, right? And then I will add sort of a static mesh, and I think we can use the default chamfer cube, something like this. And maybe I'll add a scene as well, and then we can move the static mesh and sphere to there. Also I'll add some sort of a billboard, so at the editor level we can visualize the component as well. And the sphere radius, for now I'll manually give like 200 or something like that. Then we can fix the orientation of the pivot port. So currently it's sort of like the middle, but I will sort of like increase the C depth, the C, right? Right. Now actually we can place this tester to the level. So you can see like the chamfer mesh is there and it's not actually overlapping with the level, right? Because we increase its pivot point at the C axis, right? And then now I need to detect the player collisions or player entrance to this specific sphere area. In order to do that, what I can do is maybe instead of actually increasing or adding a C offset to entire scene, I'll add that C offset only to the static mesh, right? So that our sphere is actually oriented with the level properly. See, okay, now the sphere, let's listen for this event on component begin overlap and on component end overlap. And at the begin overlap, I'll check whether our actor is a player or not by using this utility function. And if it is a player, for now I'll add a print statement, call enter, and similarly it's at the same check for the end overlap event as well. And for that I will add a print string called exit, right? Okay, then let's check whether that debug test work properly. Okay, now you can see actually when I enter the area it prints enter, and when I exit from the area it print exit, right? Now what I have to do is, instead of using this print string, let's go to the player base and I'll copy these two and paste it here, right? And now when I enter the area I can go to the far camera state, and when I exit from the area I can go to the medium camera state. Or else actually we can cache the camera states as well. Be like we can get the camera state and we can cache it, cached state. And then when I exit from the area, I'm reinstantiate the camera state based on the cached camera state value. Right. Okay. Now let's play test and see whether it's work or not. Okay. Now you can see when I enter to this specific area, right? For example, let's say this is some sort of a exploration component, right? Then it goes to the far camera state, and if I exit from there, it goes to the medium camera state, right? So it's very seamless transition, right? Okay. And let's say if I'm at a different camera state, for example, let's say I'm now at the close-up combat camera state, and if I reach there, still it goes to the required exploration camera state of our camera state. And if I exit from the area, instead of going to the medium camera state, it directly goes to that specific closed up camera state, which is the cached camera state. Right. Okay. And I think those are the stuff that I wanted to cover in this episode. Now I think we almost covered all the necessary stuff that I need to be covered considering the camera state transitions, right? So if I brief like what we have done, so basically we followed the data oriented design pattern to implement our camera manager. So we have dedicated data table called DT camera where we specify all our necessary configurations, and we have 5 different camera states, namely medium camera, close-up camera, aiming camera, sprint camera, and far camera. And based on these configured values, we have a dedicated camera manager component that is implemented here. So it will listen to those specific camera state transitions and get the required camera settings and apply it to the relevant artifacts. Right? For example, we have spring arm manipulations, camera location manipulations, and camera field of view manipulations. Right? Plus, all of these transitions are smooth. Right? They are not like jumping from one state to the another like instantly. Instead, actually, we have followed sort of like a timeline component. Right? So here you can see we have 3 different timelines to control the spring arm length, camera location, and the camera field of view. And each of them are sharing a dedicated float curve called a CF generic camera curve. Right? So this is sort of like a smoothened curve, which we can use its return value to make that specific smooth transition in between multiple different states. Right, so that's all about the camera transitions. I'll see you there. Thank you.